Hello everybody, today we're going to be going over domain range and intercepts at the IB Math Studies level. So the problem gives us two functions, right? F of x, which is outlined by the dotted line here, and g of x right here, right? And they tell us that they intersect at the points P and Q. And so part A asks us to find the range of f. Now first things first, when we look at a set of points, okay, the x values a function can take will be called its domain. And the y values that the function can take is going to be called its range. So as a separate example, if I have a quadratic function like this, with its maximum at whatever, 0, 3, and I ask myself what's the range, well, visually speaking, it's going to be these numbers, all these numbers, okay? You want to look at it from a vertical standpoint, right? In reference to the y-axis, which values can it take? So of course here it's going to be from positive 3 all the way down to negative infinity, okay? So the range here would be all values of y that are less than or equal to 3, right? Now, this is just an example to explain what range is, okay? Part A is asking for the range of f, right? So f of x. So this, visually speaking, we know that it's going to be all of these values, right? So the tricky part is figuring out what value this has, right? We know that f of x is x to the fourth minus 2, okay? And the 2 not having an x next to it means that this is going to be the y-intercept, okay? That's like a rule of thumb for all quadratic functions, right? But another way to double check is to plug in 0 for x, because if we plug in 0, it's going to be a point along the y-axis, right? Plug in 0 for x, 0 to the power 4 minus 2, f of 0 is minus 2, which gives us a set of points 0, comma negative 2, okay? So that's proof right here that this point is 0, comma negative 2. And with that knowledge, it is safe to say that the range of f is all values of y greater than or equal to negative 2. Okay, and for part B, we have to find the x-coordinate of the point P and the x-coordinate of Q. And so logically speaking, one would think that you have to equal f of x to g of x, right? Because if we equal the lines to each other, we're going to find the points where they are equal to each other, where they intersect, right? However, plugging this in, we end up with very nasty numbers, right? With values to the power 4, to the power 3. And so luckily we have the graphing calculator, right? And using the graphing calculator, what you can do is put one side of the equation as L1 and the other side of the equation as L2 in your y equals, right? So we're going to graph it with a graphing calculator. And after that, you're going to do calc, intersect, in order to find first point P and then point Q, okay? So here it's important to not get scared with, I don't know, the wacky like exponents or the fact that it's really hard to factor or really hard to simplify it. So it takes longer, but just graphing it and finding the intersect is a safe way to go. Okay, and once that's done, we end up that the x value for P is going to be -1, and for Q it's going to be 1.52. Finally, part C asks us to write down the values of x for which f of x is greater than g of x. So it's asking us when the dotted line is going to be greater than the other line, g of x, right? And so when we're looking if it's greater than the other one, it's literally if it's above it or not, okay? If it's above it, it's going to be greater. So you always want to look at it, or at least for me, it's easier to look at it from left to right, okay? So if we look here, the dotted line is greater than g of x. Then at the point of intersection, it's going to change, and g of x is now greater. And then at the point of intersection, it's going to flip over again, and the dotted line is greater than the other one, okay? I know it's kind of ridiculous to show it with a pillow, but looking at it from left to right is the way to go, okay? And so, I don't know, cover your eye or side of it. It makes it a lot easier for me. So now that we have the idea that the dotted line is greater on this side and over here, the hard part is like defining it mathematically, okay, at what point? And so, just like with any other, well, math problem, or IB in general, really, for part C, you're probably gonna have to use what you got in part B, and in part B, you probably have to use what you got in part A, right? Not always, but as a general rule, it kind of works. So, in part B, we got this value of x right here, -1, and this value of x of q of 1.52, right? And so these are ways that we can show when f of x is greater. So, f of x is greater than g of x when we have x being less than 1, which is going to be this side right here, right? Because this point right here is going to be our -1. And when x is greater than 1.52, which is going to be this point right here. And we're basically showing all the values over there by saying x less than 1, and all the values over here by saying x is greater than 1.52. So those are the points where f of x is greater than g of x. Also, the way I wrote that y is greater than or equal to -2, or x less than 1, or x is greater than 1.52, there's a lot of other ways to label it, okay? You've probably seen, like, I don't know, from -2 to infinity, right? That's one way to write the answer from part A. My point is there's lots of ways to write it, and just get used to one of them, get familiar with it, and as long as you're consistent and, well, my point is there's lots of ways to write the answer, and don't get tripped up on that. Just stick to one that makes sense to you, get familiar with it, and just always answer that way.